All right, 2.1. We're going to talk specifically about translations. That means slide and methods of showing translations. We're going to learn I can transform figures using translations. In a translation, slides all point to the figure the same distance and in the same direction. All points. We have a figure over here in which triangle ABC has been changed to triangle A prime, B prime, C prime by something called a vector, right? Vector XY. We can see the vector down here. I have measured this for you. So it says measure these distances. So we've copied this vector here, here, and here, and all of these distances. Every distance that you see from A to A prime, B to P prime, and C to C prime are exactly the same. So it qualifies as a translation because it's the same distance in the same direction. Alright. This makes all of these slides, since it's the same distance in the same direction, parallel to each other. And so how does the angle of ABC relate to ABC prime? Well, since it's the same figure, those angles are congruent. Angles are congruent as the figure has not changed shape. And that's the idea of a translation, right? Your figure doesn't change shape, it just changes position, right? It doesn't even rotate, right? It just slides along. All right. So we're going to do this with something called a vector. And you can see a vector out here, right? A vector is drawn kind of like a ray, but they only fill in the top right there. It's almost like a little arrow. All right. And a vector is a quantity that has both direction and magnitude. Direction is where you're going. Magnitude is how far, right? The initial point of the vector is called the starting point. So that would be this E right here. The terminal point is the ending point. That would be this F. And it says, hey, move every figure you have this distance and in this direction. These vectors can be shown as vector EF, or you notice they put a little letter underneath there, or it could be vector V. All right. So it is convenient to describe translations using vectors. A translation is a transformation along the vector so that the segment joining the point and its image has the same length as the vector and is parallel to the vector. So it's what you're seeing right here is these segments right here. It's the vector, that's the same as this vector, that's the same as this vector, and that's the same. So as you connect B to B prime, A to A prime, C to C prime, we're choosing to move along that, right? The same distance and magnitude as the vector. You can use these facts about parallel lines to draw translations, right? Parallel lines are always the same distance apart and never intersect, and parallel lines have the same slope. Now on the opposite side, we're going to show you a vector, and it's going to be hard. I hope this graph shows up well. You can kind of see the graph here, and here is our vector. So this vector says to go 1, 2, 3, 4. 1, 2, 3, 4 right, and 2 up. And it's kind of hard to see it, but there's a you can sort of make it out. All of these are on like a graph paper. There's little coordinate boxes there. So I go 1, 2, 3, 1, 2, 3, 4 up 1, 2, I believe. All right, which would bring my C prime here. 1, 2, 3, 4 up 2 would be my B prime here, and 1, 2, 3, 4 up 2. My A prime would go there, and this would be, let's put primes on all these. That would be my translation. All right. This says take everything and move it 1, 2, 3 to the left, and 1, 2, 3, 4, 5 up. So I go 1, 2, 3, 1, 2, 3, 4, 5. All right, and this is 1, 2, 3, 1, 2, 3, 4, 5. There's D prime and C prime A, the same thing. So 1, 2, 3, 1, 2, 3, 4, 5, and I can tell that B is just going to be a couple to the left because it's going to have the same shape. There's A prime and D prime, and there it is. We've slid that vector. This vector right here tells me how far and which direction. Just like this vector right here says go down 2 and left 1, 2, 3, 4, 5. So I take them all. Down 2 and 1, 2, 3, 4, 5. There's C prime. This way, right? Down 2 and 1, 2, 3, 4, 5. There's A prime. Down 2 and 1, 2, 3, 4, 5. There's B prime. And there's my new triangle. Put my primes on there. Anyway, that's how a vector can be shown when they put it on a graph for you. But there's other ways to do it, and we're going to talk about that next. Talk to you soon.